Welcome back, Life Sciences. I hope you took a nice little break. As I always say, get those muscles going, clear that head and all the oxygen going through it. What are we concentrating on today? We're looking at all the good things that microorganisms, what they do in our environment. As I said to you, we concentrated a lot on the diseases, and this time we're looking at what functions do microorganisms have that we cannot live without. Okay, so let's carry on with that. There are a few terms up on the board here again that you might need to be more familiar with. Some of them, might be, as I said, might be strange to you, but as we go through the lesson, I will explain the concepts and they will be a lot clearer, but you must remember them, okay, and you need to learn them. Okay, the first word is biotechnology. And this is a concept you're going to look at much later when you look at, if you do more of the grade 12 syllabus. And basically what biotechnology is how we're able to use living organisms for our benefit. And a lot of the time it's a concept of, I won't say genetic modification, where we change the genes of certain things to be able to help us, or use things in order for our benefit. Okay, what's the first one we're going to look at? Now, the first one is this concept of antibiotics. Now, I know a lot of you, I'm sure, have, let me change the color back again, have had antibiotics, you've been sick, and antibiotics were a huge, big discovery. Now, it was discovered by Alexander Fleming, He did a little bit of an experiment. He was actually quite a dirty man, just by the way. And what he did was he grew a fungus called penicillin. And he noticed that wherever the fungus was, there was very little bacteria. And this is where the whole concept of an antibiotic is. An antibiotic is a medicine, and initially it was a fungus that they could harvest, that they could treat bacterial infections for. So when it comes to antibiotics, guys, this is very important, bacterial infections. Not fungus, we used a different medicine for fungus, and definitely not viruses. Antibiotics are drugs, that we use specifically to treat a bacterial infection. And at the time when it was discovered, there was the world wars were on. And lots of men were dying on the battlefield, not from being killed in war, but from being injured and dying from bacteria, bacterial infections. And this penicillin gave a whole new concept to healing. So antibiotics help people to heal. But the problem with it today is that we have too much of it. Lots of times people are given antibiotics and they don't finish the course. And what happens is they don't kill all the bacteria, and the bacteria are able to mutate and become back resistant. Remember when we looked at TB? There are certain strains of TB that are resistant to the antibiotics, and the treatment that people need. So when it comes to antibiotics, sometimes we just need to take the foot off the pedal a bit and not always use it for any single time we just feel a little bit sick. But as I said, a huge, big, I won't say invention, helping us be able to cure little things that often killed us. Okay, now the concept of vaccinations. And those of you who are living through the COVID times, it's a huge, big concept that we're looking at. And a lot of you, when you were small, you were immunized. Now, what it is the following. These two concepts are the following. When we immunize you, usually what we do is we take, I'm going to use a virus, for example, we take a little bit of the virus, and we take away the danger part of it, if I could use it. We make it a weak formed, and what they do is they inject that virus into your body. Now, your body has a natural immunity system, and what does that do is a whole reaction takes place. That ultimately what your body does is that it remembers, that virus that came into your body, and it produces something called an antibody. And that antibody stays in your system. So if a virus attacks you, that same one, your body has got a memory. It says, oh, I know this virus, I think I can, all right, I think I can attack it. And those antibodies then, all right, attack the virus, and basically, doesn't mean you don't get sick, but it usually means that you're not going to get as sick. So when we're talking about all these vaccines, when it comes to COVID, what it is we're putting something inside us that stimulates our immune system to make a response. And that response is an antibody or something that is going to fight that virus. It's not a cure, all right, and it's not a prevention. It's not going to stop us from getting sick. But what it could do is if we do get sick, maybe it's just mild symptoms. We're not going to be so sick that we might die. And that's the whole concept of vaccinations. And as I said, for those of us going through all the COVID things, vaccinations are huge. When are we going to get them? What are they about? Do I trust it? There's a lot of things to consider when we look at this. And as I said, what is biotechnology? Us making things to help us. So this is the whole concept. As I said to you, we put some kind of the virus into a vaccine. That's what a vaccination is. A vaccination is the actual injection. And it goes into our body and it produces this antibody. Guys, the next concept, all right, called biotechnology, is genetic engineering. What does genetic engineering mean? It means we change the DNA. Now, for those people who are diabetics, for some reason, there's lots of reasons, they don't produce the hormone insulin. All right. And what used to happen quite a few years ago, people who were diabetics, they had to use pig insulin. All right. And as you can imagine, certain, all right, groups, races, religion, pig products are a no-go. Plus also it's a pig and it's a human. So they might not be compatible. So somebody taking the pig insulin might have an adverse reaction. So have a look what happens over here. This is called genetic engineering. So we take a human cell over here and we cut out the gene to make insulin. So what do we use? We take a bacteria, all right, and in the bacteria cell, they've got a little round piece of DNA. And we cut it. So it's easy. It's cut and paste. We cut it out, and what do? We stick in this gene over here. So you see that red? I put it into the bacteria. All of a sudden, the bacteria has got the gene to say, oi, I need to make human insulin. And it does. And bacteria grow so quickly. And what message have they get? Make human insulin. So what are scientists, doctors, pharmacists, all those in the medical biotechnology, they take that human insulin, and diabetics can inject human insulin. Right, so they take it out, put it into a bacteria, which is a microorganism, and there we're able to have proper human insulin for people, and they won't be able to reject it. Okay, guys, I think some of you might be familiar with this concept, right? Making beer, making alcohol, right? Traditional beer. So obviously in a lot of the African cultures, making their own beer, right, is part of the culture. Making your own alcohol, right? When we went through lockdown, I think lots and lots of people, when we weren't allowed to have alcohol, all of a sudden started to make their own alcohol. So why is it on the list? Guys, check at the top there. Yeast. Yeast is a fungus, all right? And when we make any kind of alcohol, if we're making our traditional alcohol, or if we're having a good old Castle Light or a Castle Black Label, if we're having a glass of wine, all right, or if we want to do all this craft beer that we want to do, all of it involves fermentation. And fermentation is a process we're going to look at later, all right, in the series. But we use yeast, we use the sugar, and we put it together, and a natural process that yeast fermentation occurs, And what is the result? Alcohol, right? Alcohol. So a lot of people are reliant on microorganism yeast to have your alcohol, whichever way, your homemade one, be careful, right, or the ice cold one that you have. Bread. Oh, I love bread. Right, that's why it goes all the way to the hips. Bread. How do we make bread? Lots of recipes for today that says make bread without yeast. But how have we made bread? We use yeast. All right, the microorganism, it's a fungus, and we use it to bake breads. Again, that fermentation process. And a lot of our bakeries, bread. All right, we love bread and jam. Yummy. Okay, this is a food group for me. For those of you, I love cheese. Cheese is the most amazing thing. I cannot live without cheese. And as you guys remember, a cow doesn't just go tonk and out pops the cheese. Right? What do we use? How do we get something so solid? Quite simple. We take the milk from the cow and we put bacteria in it. And that bacteria makes it all lumpy. We call it curd. And we just basically take all the moisture out, and there we've got delicious, all right, lovely cheese. Now have a look at you, those of you, right, who like blue cheese. Everybody goes, oh, gross, don't like it. So what do? We take the cheese and we put fungus in it, right? And the fungus gives it the taste and the smell. Some of you don't like it, but it's fine. Yogurt. Right. Yogurt is packed full of bacteria, really healthy for us, gives us that good bacteria that we need, right, in our colon that helps us produce all that vitamin K. So that's how we constantly are using all of these microorganisms. Guys, have a look here. Right, we call it mas or masi. Some people say, oh, it's cultured milk. It's the same thing. And you can use it in your baking. I know I make a bread. Can you believe it? Yes, love bread. And what do I add? Cultured milk. I don't add yeast, and I have cultured milk. And what is cultured milk and what is amazi? All it is milk, right, which we add bacteria again, right, and we ferment it. We change it and it becomes quite lumpy, but it gives, all right, gives the food, or you like to drink it, a nice taste. Okay, guys, that's all that we're going to have for now. We're going to have a quick break and we'll be right back.